Okay, these notes are over the mole. And in chemistry, a mole is not the nasty little creature here or the big gross thing on your face, oops, or a spy. It's actually a counting unit. So like a dozen is 12, or a pair of shoes would mean you have 2 shoes. A mole is 602 billion trillion, or 6.02 times 10 to the 23rd. This is called Avogadro's number. This is Avogadro. He looks like a little mole. So a mole of particles is 6.02 times 10 to the 23 particles. If you have a mole of carbon atoms, you have 6.02 times 10 to the 23rd carbon atoms. If you have a mole of water molecules, you have this many water molecules. If you have a mole of salt, you have this many salt molecules. If you had a mole of anything, it's going to be, this is how much you have, that big number. Now, not all moles are going to weigh the same, right? A dozen elephants does not weigh the same thing as a dozen rabbits. So if you have a mole of mercury oxide, it's not going to weigh the same thing as a mole of sucrose or a mole of copper. It's all different because they're different elements. So how do you know how much something weighs? Well, somebody already did all the conversion for you, and they're found on the periodic table. So the mass of 1 mole of each element is on the periodic table. A mole of carbon atoms weighs 12 grams. A mole of magnesium atoms is 24.3 grams. So what does the chemical formula tell you? Well, it depends on what the question is asking. If they're asking for small scale, then you can read it. Like, let's just take hydrogen here and not worry about the equation. If they're asking for a small scale, 2 molecules of hydrogen, that's how you could read that. Or you could also say 2 moles of hydrogen. So this 2 could mean a couple different things. So you really have to read the question and understand what they're asking you for. Okay, so how do we find the molar mass of a molecule or a compound? So if it's an element, all you have to do is look at the periodic table. So if they give you a compound and you want the mass of that compound, you just add them up. So 1 mole of sodium chloride, you have 1 sodium and you have 1 chlorine. So from the periodic table, a mass of sodium is 22.99 and the mass of chlorine is 35.45. Now, you just add them up. And when you do this, when on the periodic table, looking at the masses, you need to round to 2 decimal places, okay? And your units for this is grams per mole. So 1 mole of water. Now here I've got 2 hydrogen, right? 2 hydrogen, 1 oxygen. So that means I need to multiply the mass of my hydrogen by 2, plus my 1 oxygen, and my units are grams per mole. Okay, so now that we have grams per mole, we can solve mole problems with dimensional analysis. And it's just like you did at the beginning of school in August, where you went from meters to millimeters or grams to kilograms. Start with what the problem gives you, set up your conversion factors, and our new conversion factor now is molar mass, which is gram per mole, and it's always 1 mole, or 1 mole over gram, whichever one you need to use. And then you multiply across the top and divide by what's on the bottom. Okay, so here is a nice little diagram. You always have to go through moles. So if you ever get lost, go to moles and you'll probably start getting on the right track. So here's our first example. Aluminum is often used for the structure of lightweight bicycle frames. How many grams of aluminum are in 3 moles of aluminum? So I'm going to start with what the problem gave me, which is 3 moles of aluminum. And I'm going to use my new conversion factor. I know in 1 mole of aluminum, there's 26.98 grams. I got that from the periodic table. Okay, so my moles cancel, And I'm left with 3 times 26.98, which is 80.94. I need 3 sig figs, so 80.9 grams of aluminum. How many atoms of copper are present in 35.4 grams of copper? I'm going to start with what the problem gave me, 35.4 grams of copper, and I want to go to atoms. Well, I have to go to moles first. So 35.4 grams of copper. I know from the periodic table I can use the molar mass to get to moles. That'll get rid of my grams. But I want atoms, not moles. So I'm going to use Avogadro's number. 1 mole of anything, right, is 6.02 times 10 to the 23rd atoms. So that leaves us with 3.35 times 10 to the 23rd atoms of copper. All right, try these problems and we'll check them in class.